Welcome children. Our today's topic is chemical bonding. You might have seen in the world of chemistry, you have seen many compounds. And say, I am say taking this chalk piece and this chalk piece or this duster. When I keep them in contact, only they are combined or they are kept physically. But so far these chemicals are concerned, the chemicals they cannot be combined physically. If they combine physically, we can simply say mixture. But if they combine chemically, we will tell them that is a chemical bonding, it is a compound. Why? Because one molecule of water there, water, the general property of water is when you pour the water in fire, the fire extinguishes. And the same water is made of two different components, that is oxygen gas and hydrogen gas. Oxygen is a supporter of combustion and hydrogen itself is an inflammable gas. So both are less or more supporting to fire. But when oxygen is having a property, hydrogen is having another property. But once oxygen and hydrogen are combining chemically to form the water, and whenever that compound is poured on fire, fire extinguishes. That means in a chemical compound what happens? The chemicals or the elements they are involved in making the compound, they lose their original property. Why? Because they are combining chemically. But if they would have been combined physically, that will be called a mixture, and in physical combinations, the components of each and every component of the mixture will be retaining their own properties. So let's come to this chemical bonding where one or more elements are combining to one another chemically to form a compound. And this chemical bondings are of two types. The two types of bonding is, one is called your ionic bond or electrovalent bond. The other one is covalent bond. Ionic bond where there is a donor and there is a acceptor, and in case of covalent bond there are sharing. So why actually exactly this chemical bonding takes place, you should learn first of all. That as we people, we want to be stable in our life, and that intention of to be stable, it is there even in every atoms. Then what is the condition to be stable is, an atom, if it retains 8 number of electrons in its outermost orbit, if an atom retains 8 electrons in its outermost orbit, then that particular element is said to be stable and it never react with any other element or atom further. But whatever elements are not having 8 number of electrons, then they will be in search of other electrons so as to make it 8. So in the process of searching, acquiring or losing the number of electrons to make 8 number in their outermost orbit, make the elements to combine one another chemically. That is only called your that is what results as your bonding. And you know the electronic configuration. In another video, you can watch the electronic configuration video of our series, so that you can able to see that how the electrons are segregated in first orbit, second orbit, third orbit, and so on. And so far this chemical bonding is concerned, the outermost orbit is taken into account. Okay. Say for example, I have taken two element like sodium, chlorine and calcium. You know sodium, the symbol is Na, chlorine Cl, calcium Ca. Atomic number of sodium is 11 and chlorine is 17, calcium is 20. So in the first orbit of sodium 2 electrons, second orbit 8, third orbit is 1. Chlorine is first orbit 2, second orbit 8, third is 7. Calcium first orbit 2, second 8, third 8 and fourth is 2. This is what the electronic configuration. Now, so here what is happening in electrovalent bond, to acquire 8 number of electrons, elements like sodium, they will be seen that outermost only 1 electron is there, and to make it 8, 7 is required, 7 other electrons are required. And element like chlorine having outermost 7, and to make it 8, 1 more is required. So it is easier for the chlorine to acquire 1, but it is very difficult for sodium to acquire 7. So what alternatively sodium does, sodium instead of expecting 7, it wants to donate the 1. Once this particular electron is donated, then sodium will be having 2 8 and this is already donated to someone. Then ultimately this 8 will be standing as its outermost orbit and the number of electrons are 8, and so that sodium can claim that it is stable. And suppose this 1 can be given to chlorine. Chlorine 7 plus 1 becomes 8 and outermost orbit chlorine will claims 3 orbits, 8 electrons, and it is so stable. I have given that one diagrammatically. This is a sodium. First orbit are 2 electrons, second are 1, 2, 3, 4, 5, 6, 7, 8, and third orbit is 1. And coming to chlorine, first orbit are 2 electron, second is 1, 2, 3, 4, 5, 6, 7, 8, and third is 1, 2, 3, 4, 5, 6, 7 are there. I have represented the electrons of sodium is round and chlorine is cross, but in fact all the electrons are same in structure. To identify sodium electron and chlorine electron, I have given round and cross. And now in this picture, I took only the outermost shell. So in the outermost shell, this is sodium, the symbol of sodium is Na. This is chlorine, symbol of chlorine is Cl. The outermost orbit of sodium is having only 1 electron. I have given here 1 dot. And outermost orbit of chlorine is having 7. I have given 1, 2, 3, 4, 5, 6, 7. Now what is happening here? Sodium is donating 1. The arrow mark represents is donating. Once the sodium will be donating the last electron, automatically this particular orbit will be disappearing, and this one only stands as its outermost orbit, and that orbit has 8 electrons. So now sodium is stable. And that single electron whenever going to chlorine is already having 7, and this one more is added, 7 plus 1 more is added, and ultimately chlorine will also have in its outermost orbit 8. Now sodium and chloride, the particular compound is formed, and here what happened, sodium is donated and chlorine is accepted. Because sodium is donated, it is called, it is plus, and chlorine is accepted, it is minus. So this electrovalent bond or ionic bond always takes place between metals and non-metals, because metals will be always donors and non-metals are always accepted. Question may be asked that why metals are donors? Metals are donors because they will be having in their outermost orbit either 1 electron, 2 electrons or 3 electrons. So it is 1 means it is easy to donate 1 rather than accepting 7. 2 means easy to donate 2 rather than accepting 6 to make 8. 3 means it is easy to donate 3 rather than attracting or accepting 5 more. That's why simply the elements which have in their outermost orbit 1 electron, 2 electrons or 3 electrons, they will be donating and they called metals. And similarly coming to non-metals, if any particular element is having, atom is having in its outermost orbit 4 electrons or 5 electrons or 6 electrons or 7 electrons, then they are non-metals because it is easier for them to accept. Coming to 4 you mean accepting is 4 more electrons or donating also 4 electrons, but in general the atoms which have 4 electrons in their outermost orbit, they have the tendency to accept rather than donating. So elements having in their outermost orbit 4, 5, 6 or 7 number of electrons have the tendency to attract electrons. That's why they comes under the category of non-metals. So this is what the ionic bond that forms between metal and non-metal. Coming to another case, calcium having atomic number 20, so the electron configuration first orbit 2, second orbit 8, third orbit 8, fourth is 2, 2 plus 8 10, 10 plus 8 18, 18 plus 2 20, and chlorine 17, 2 8 7. So like before, I am just drawing the outermost orbit. This is calcium. Calcium is having in its outermost orbit only 2 electrons, here 1 electron, here 1 electron. And chlorine is having in its outermost orbit 7. So chlorine 1, 2, 3, 4, 5, 6, 7, and one more 1, 2, 3, 4, 5, 6, 7. Now calcium will be combined with the chlorine by donating 2 electrons. But chlorine needs only 1 electron. That's why 2 different chlorine atoms are required, so that the calcium can donate 1 chlorine atom, 1 electron to 1 chlorine atom, another electron to another chlorine atom, so that the compound will be formed by CaCl2. By donating 2 electrons, automatically calcium will be losing its outermost orbit then with 2 electrons. So this 8 will stand as the number of electrons in its outermost orbit, so it can able to claim it is stable. And similarly, chlorine by receiving one chlorine by receiving one electron from calcium, it becomes 8 here. This is 7 plus 1 8, and these are 7 plus 1 8, so that 1 Ca and 2 Cls will become stable, and the compound form will be CaCl2. It is written CaCl2 but not Cl2Ca. It is not written. This way of writing is wrong. Why? Because the donors or which are positives generally written first and the negatives are written next. So this is the wrong way of representing, but writing CaCl2 is the correct answer. And here I have shown the dots, the electrons in the form of dots, and how it transfers from one particular atom to another particular. This is given by your Lewis dot structure. Let's come to the second type of bonding, that is covalent bond. This covalent bond, it takes place between non-metal to non-metal. Two non-metal may be of the same non-metals or different non-metals. Because these non-metals, you know, they have in their outermost orbit the number of electrons as 4, 5, 6, 7. That's why they never donate electrons, but always they will be accepting. However, if a non-metal interact with some other non-metal, there some other kind of bonding takes place, that is called covalent bond. It generally happens by sharing the electrons. So none of the two non-metals will be donating their electrons, rather they will be sharing. Let's take the cases. See, I took three elements like hydrogen, symbol H, atomic number 1, so only one electron. And oxygen, symbol is O, it is having atomic number 8, so total number of electrons are 8. In the first orbit it has 2 and second orbit it has 6 number of electrons. Coming to nitrogen, the symbol is N and atomic number is 7, so it is having even 7 number of electrons. First orbit are 2 electrons and last orbit, that is 5 electrons. So for that bonding case, I am taking only the final, the last orbit only into account. Now let us see one hydrogen, between a hydrogen how the bonding takes place. This is one hydrogen and in its orbit one electron is there, and that is another hydrogen and in its orbit there is another electron there. To differentiate, I wrote one is a circle, another is a cross. Now what is happening? None of these elements are donated or accepted. What happens is sometimes the electron of first hydrogen revolve in the orbit of second hydrogen, and sometimes the second hydrogen will be having its own electron and one more electron from the first hydrogen. It claims that I have 2 electrons. It has 2 electrons. Similarly, sometimes the second hydrogen donates its electrons to the first, so it keeps revolving in the first hydrogen's orbit. So first hydrogen claims it is 2. So because they are sharing, ultimately this hydrogen claims 2 electrons and that hydrogen also claims 2 electrons in the orbit. Because the orbit is only one and one orbit means it has the capacity of 2 electrons, so it is satisfying the duplet rule. But whichever elements are having more than one orbit, they have to keep only 8 electrons. That is called your octet rule. So in this case, this is called octet. Let us come to the second case, oxygen. Oxygen having in its outermost orbit 6 electrons, 1, 2, 3, 4, 5, 6, and that particular oxygen 1, 2, 3, 4, 5, 6. So here this oxygen claims it has 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there because the other 2 electrons from the second oxygen whenever comes to here it claims 6. Similarly, the second oxygen 1, 2, 3, 4, its own 5, 6 and these two 7, 8. That second oxygen also claims 8 electrons are there. So it is what? The bonding between oxygen. So O and O, it takes place O2 because 2 oxygen O2 here H2 has formed. This is what? A single bonding, one single bond. But here what happened? 2 bonds with electron, 2 electrons they said no. So one double bond has taken place. Coming to the third case, in case of nitrogen you have 7th atomic number. So outermost orbit only 5 electrons are there. So this nitrogen 1, 2 and this is 1, 2, 3, 4, 5. This particular nitrogen is 1, 2, 3, 4, 5. So first nitrogen is claiming 1, 2, 3, 4, 5, 6, 7, 8, and second nitrogen also claiming it is 1, 2, 3, 4, 5, 6, 7, 8. So both are having 8. So N2, the nitrogen gas, nitrogen molecule takes place. It is one triple bond. Bond 1, bond 2, bond 3. Triple bond. That's why 3 lines are given. Double bond here given 2 lines and hydrogen given single bond. Coming to one more case, NH3 ammonia. Nitrogen is having its 5 electrons. 1, 2, 3, 4, 5. Hydrogen having its 1 electron. This hydrogen 1, this hydrogen 1, this hydrogen 1. So first hydrogen its own electron and one from the nitrogen, 2 electrons. Hydrogen stable. This hydrogen also its own electron and one from nitrogen. It is also stable. This hydrogen also its own electron and one from nitrogen is stable. So 3 hydrogens are stable by receiving or by sharing the electrons of nitrogen. On the other hand, this nitrogen its own 1, 2, 3, 4, 5, 6, 7, 8. This nitrogen also having all 8. So here you are getting this hydrogen is showing a duplet rule and nitrogen satisfying octet rule. So in that case what? NH3, N and H3. This NH3 molecule is formed. Here you got single bond, single bond, single bond. 3 single bonds are formed. So this is what all about these bondings. That is ionic bond and covalent bond. You have another type of bond that is called a coordinate bond. Some sort of the combination of ionic and covalent. That is the beyond the scope of our book. So that's all with the chemical bonding for today. Thank you all.